Hope you guys are doing well. This is our makeshift board today. That's what we're going to work with. Hope all of you guys are doing well. I'm going to try to fit myself on the screen. It's too much of me and too little of a screen. So, this is Franklin's. I asked her to borrow it, so we'll see how it goes. Today, we're going to be working with a non-linear system of equations. Okay, we've heard that before. We're going to run this as an ed puzzle. So every time I ask you a question, you guys are going to go ahead and be able to enter in answers. So the first, actually, is what is this system of equations? What is this system? All right. So hopefully you answered that there. A system of equations is when we have two or more equations on the same coordinate plane. We're trying to identify where they intersect. We're going to work with non-linear. When I say nonlinear, we're going to really focus on a quadratic function today and a linear. So you have one linear function, we have one quadratic function. We should have an idea of what they look like. And we know what a quadratic function looks like. We know what a linear function looks like, right? Quadratic is we have our parabola, right? Parabola. We have a linear function, which will be our line. How many solutions can you have? How can these two things on a coordinate plane look? How many times can they intersect? Second question of the day. All right. So based on that, hopefully you've wrote down your answer. And actually, we can have three types of solution. The first one, hopefully, was pretty obvious, and that's no solution. All right. We can have on a coordinate plane, let's say, here's our coordinate plane. We can have a parabola, a quadratic, and we have our line, and where they don't intersect. That's going to happen. That's our first option. So this is no solution. Next on our coordinate plane, this is probably the second most obvious answer, is we can have our parabola and we can have our line. To me, that looks like two solutions. Now, the last one is the one that's a little harder to see. We have our coordinate plane. We have our parabola. Oop. Sorry. Not super easy to write this. And we have one solution. When we have one solution, this line just touches the parabola. It's tangent to the parabola. So it's only going to have one solution. Okay. Typically, for us, it's going to be a horizontal line, but you could also have a line that has a slope of non-zero and have that work out. Okay. So those are our three types. Hope you guys are having a good day. I'm going to pause this one and then probably go in and solve a few for you, okay? All right, we're back. So, no, we're not. All right, our next question of the day. How would you solve a system of equations? So we have these non-linear system of equations. How do we solve that? Think back to when we solved linear equations before. How did we solve them? No, 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 no. So hopefully your answer was we solve it first by graphing. The reason why we solve by graphing is it gives us a visual. All right, we understand what this looks like. The intersection point, we can see it. It's concrete. It's time consuming though, right? When we graph, it's great. We got to make your coordinate planes, right? You have to do all these things that are time consuming. So not a great effective way, but a way we need to do, right? Um, the next way is probably our most efficient way. I think most of you guys liked it. Substitution. We can solve these by substitution. Um, Now, substituting is a little bit more complicated because you're substituting a linear and a quadratic. Um, but the substitution works the exact same way. We'll do an example of substitution today so you guys can see that. Um, Graphing, I will not do a graphing example. I'll post that on the website that you can go through and see a graphing example because I think that's pretty self-explanatory. And once you see it, you're graphing a quadratic, you're graphing a linear function. Where do they intersect? And you can use Desmos to help you with that. When you're solving using substitution, it is a little harder. So let's get on with it. All right, we have our system of equations. So go ahead and copy down that system of equations. Um, it is y equals x squared plus x minus 1 and y equals negative 2x plus 3. So we have our quadratic function. We have our linear function. We need to solve them using substitution. Now you can always check your solutions. A couple different ways you can find a substitution calculator. This will work in that substitution calculator if you type it into Google. That'll give you the steps for it if you do get stuck. I know my keys have been having a hard time getting uploaded, so that might not be a bad way for you to do this. You can put this into Desmos and get that visual. Um, but how else? How do we solve this? How do we get this started? Well, they're both equal to y. And if they're both equal to y, we can substitute them in. We can take negative 2x plus 3 and substitute it into y. So you end up, and let me get my second color here. You end up with, instead of y equals x squared plus x minus 1, we end up with negative 2x plus 3 equals x squared plus x minus 1. And there's a substitution. We substituted in what y was equivalent to. Now, once we're here, and this is where my whiteboard, my limited whiteboard is going to be tough. It's hard for us to kind of work all this through. This is our equation we need to solve. The problem is, what type of equation is that? You're correct, I hope. It's a quadratic equation. We solve quadratic equations a few different ways. We can factor, we can use square roots, we can complete the square, we can use the quadratic formula. So now we're pulling back everything we did in unit 11, or sorry, unit 10 before we left for our e-learning. We're bringing all that back. And now we're going to go ahead and solve this quadratic. So I'm going to add 2x. I get 3 equals x squared plus 3x minus 1. I'm going to subtract 3. We get 0 equals x squared plus 3x minus 4. So we're here, whenever we solve a quadratic, we first want to set it equal to 0, see if we can factor, see if we square root's our best option of completing the square. In this case, hopefully we see that I can factor this, right? So I'm going to factor this and say 0 is equal to, what are two things that multiply to get -4 but combine to get +3? That is x plus 4 and x minus 1. Once I am at this spot, I set, because these two factors are set equal to 0, we know x plus 4 is equal to 0, or x minus 1 is equal to 0. I solve these individually. Subtract 4 on the first one, I get x is equal to -4, or add 1 on both sides, and we get x is equal to +1. And we are done. Our two solutions are from when x is equal to -4 or x is equal to 1. Oh, wait, that can't be our solution yet. Why? Well, the reason why these are not solutions yet is these are just the x coordinates. What this tells us is that these two functions are going to have two solutions. One of the solutions is going to have x coordinate of -4. The other solution is going to have an x coordinate of 1. Those are just the x coordinates. So I need to find the corresponding y. So one of my solutions will be -4 comma something. The other solution is going to be 1 comma something. Now to do that, I would substitute this into the easier equation, which is our linear, -4. -2 times -4 is 8. 8 plus 3 is 11. 1. -2 times 1 is -2. -2 plus 3 is 1. And my two solutions should be -4 comma 11 and 1 comma 1. Have a great day, guys. I look forward to doing this again. And a few more days until break. We'll probably have one of those fun days tomorrow where we identify something we can do for our families, for ourselves, kind of take math out of it, maybe try to influence math in there. But have a good day, and I'll talk to you later.